Hi, welcome to the Open Compute Global Summit. I'm Sean Varley, and I am the director of our product marketing group at Ampere Computing. And I'm going to introduce you to Jayesh.
I'm Jayesh Shah. I'm responsible for platform strategy at Ampere.
Thank you, Jayesh. Okay, we're going to start this floor talk off, and we're going to just to introduce you to Ampere and what we do. And then I'm going to pass it over to Jayesh to talk to you about some of the exciting platforms that we have. If you're not familiar with our company, we were here last year, and the year before that. So it's a pretty big show for us, and we like to come out and show kind of the strength of the ecosystem. And one of the most exciting things is that this year is our biggest year ever in terms of having a large ecosystem that's out there supporting these ARM-based server compute platforms. So we're going to introduce you to those today. And I'm going to start out with a hearkening back to Jeff Wittick's discussion at our keynote earlier this morning. Because one of the main things that we like to show people, we like to talk about and make sure people realize is that server efficiency is fundamental to data center growth because of the extreme amount of heat and power consumed by the server infrastructure in data centers. And so if you look at this, what we've shown here is that by 2025, if you want to actually build out the compute needs of that 2025 future data center, you could essentially have two choices. You could kind of take a look at it and double the power using legacy x86 approaches, or you could actually save 20% power as compared to today and 30% of your data center space. So this is a huge value proposition just by addressing the problem at the core, we like to call it, and that really starts from industry-leading performance, which we'll talk about, and also industry-leading power efficiency. So we have been a big contributor of standards and basically contributions back to the Open Compute project, and we continue to do that. We announced our latest contribution here at the show earlier today with our Mount Mitchell next generation platform motherboard spec. Okay, so sustainability is fundamental. We talked about that. And I'm going to just go through a few of the characterizations or capabilities that really differentiate a cloud native processor, which is what we produce. Jayesh earlier today reminded me, remember to talk about what we actually sell, which is silicon, right? We sell server silicon, and our products go up to 128 cores today. They're very scalable, and one of the things that makes them very different is that you can utilize these servers all the way up to 100%. When we build our products, we build them with the intention that they get entirely used. And that is one of the most sustainable ways to stand up a server infrastructure, is to make sure that you don't leave anything on the table when you're standing up common cloud native workloads. So run them at 100%. They are very linearly scalable. In other words, that they have, you can use as much capacity and have each incremental ask of the server return the same amount of performance. You can fully populate your racks again. Because our servers are so much more power efficient, you have the ability, essentially, to be able to fully populate racks. And we've got an analysis I'll show you in just a second about kind of how that works. Addressing power at the core, just use less power. That is our mantra. That is the way to get to lower thermal density and, of course, highly utilized servers and highly utilized racks. So I'm going to show you really what you can get out of using these highly power efficient servers with standard workloads in the data center to maximize rack performance. Okay. So our advantage kind of starts with that fundamental power efficiency I talked about. I like to use this slide to kind of introduce how we do this on cloud native workloads. These are workloads that are everyday household names in typical data center infrastructures. We're talking about web services. You have Nginx, very, very popular HTTP server, Redis, a memory caching service, video services using X2.264, and finally Hadoop, which is another household name in big data and data lake implementations. So looking at that, we start with extreme performance. And the way to read the chart here on the, well, I guess, the left of the screen for you, is essentially the actual performance advantage that we have over the x86 competition in that, running that Nginx workload at socket level, full performance, full out. And then if you look at the performance per watt, the power efficiency, you're really getting almost up to 4x power efficiency advantages by using a cloud native processor like ours. The second one is really around consistency and predictability. We are very, very predictable. We do not allow noisy neighbors to essentially disrupt the program in progress on any other core in the processor. And this is shown here by using Redis in a server and then interrupting it with encode operations, X264 operations. So every time you see that dip in that graph there, there's a noisy neighbor turning on and off. Those dips, while not shown on this, can be up to 50% of the actual performance of Redis jumping around due to that noisy neighbor activity. You can see Ultramax, rock solid at the top. Scalability. We actually do very, very well, as I said earlier, turning on the demand of the workload incrementally as you turn on and light up those cores. x86 tails off. This is a very, very well-known and understood situation with everything from frequency scaling to the hyper-threading that's in x86 cores. And finally, that low power. Less power is our new power, as we'd like to call it. And essentially what you're showing here is that under very high utilization, we're talking 95+% utilization, you can actually run a full 100 watts below the thermal limit of the processor at that utilization. That is a very big statement and essentially allows you to get 40, even 50% better power efficiency under high utilization and usage. So these are the characteristics of a cloud native processor. Okay, finally, I'm going to pass it to Jayesh to talk about our platforms, but first he did want me to remind you that we do sell processors. Up to 128 cores I talked about, PCI Gen 4 in this current generation, Gen 5 in the actual generation we just introduced and contributed to the OCP Foundation this week. And 128 Gen 4 lanes, 8 channels of DDR4 at 3200. And these are the fundamental characteristics of a cloud native processor if you wanted to kind of take the lid off. But I'm going to pass it over to Jayesh to talk to us a little bit about platforms, which is really where the magic comes together in terms of delivering servers at scale. And we've got an exciting list of partners to introduce you to. Jayesh.
Thanks, Sean. So I wanted to talk about the ecosystem, both on the hardware side and on the software side. So having a great processor is good, but in addition to taking the processor, putting it into a system and actually deploying it, or for folks that are interested in actually sampling it, one second.
There you go.
We have a fairly healthy ecosystem, whether you're interested in working with an OEM like HPE or Inspur or Supermicro, or whether you're interested in going directly to a ODM like WeWin or Huachin or Foxconn. There are a lot of choices in terms of what's available from the ODMs, what's available in the market that's based on Ampere Ultra. You can get half-width nodes, 1U, 2U, if your workload is based on storage or general compute, or if you're trying to do something related to cloud gaming, there are options available for you to sample and test your workloads on. We have a one-socket server available from HPE. That's the RL300. That's a Gen 11 server from HPE. You can stop by their booth and take a look at it, or you can stop by our booth if you want more information. It supports OCP 3.0 mezzanine. It has support for the ILO manageability, or you can get manageability that's OpenBMC. We also are starting to sample Mount Bonnell, which is a half-width from Foxconn. They're available in E1.S form factor. If there are customers that are interested in high-density drive config, then the E1.S may be an option. The other option is for general compute. You have a choice with U.2 drives as well. And then we have a family of servers from Supermicro that are based on workload. So if your workload is general compute or storage, Android in the cloud, there are specific SKUs that you could get from Supermicro that are tailored to your use, to your workload. You can, again, stop by at the Supermicro booth or at the Ampere booth and take a look at the server, ask us for more information. We're happy to answer questions around Mount Hamilton. In addition to the one-socket servers that I highlighted, we also have quite a few two-socket servers from Inspur, Huachin, Foxconn, and also Gigabyte. So if your workload, your usage requires 1U servers, 2U servers that are two-socket, there are quite a few vendors that are offering Ampere-based servers for customers. A number of these are actually being deployed by Tier 1 CSPs and also Tier 2, Tier 3 CSPs. I think that's, oh, yes. And then for the edge, we have offerings from AD-Link. They have a COM HPC board, and they also are working on providing a developer system in a workstation form factor. So there's work that Ampere is starting to do around edge, and if that's something that you're interested in, come talk to us. We can figure out ways to partner and help you deploy Ampere-based servers for the edge as well.
Well, we want to thank you. Thanks, Jayesh, for talking to all those partners. As I said earlier when I opened this, this is a huge expansion of our ecosystem. So I invite you all to come visit us at either our booth or one of the many partner booths that Jayesh introduced, and ask us questions. Give us kind of your thoughts. What do you think about this? Sustainability is a huge thing. This is something that obviously the OCP is leaning into very heavily. We're a big part of that, and we're supportive of it. So we'd like to talk to you about that. Or if you just have questions around cloud-native processors, or where you can kind of get a hold of one, let us know. I would like to mention that we are also showing a few demos in our booth. So if you want to come and check out these services I mentioned, web services, video on demand services, AI services, AI inference, computer vision and natural language processing, or recommendation engines, which Alexis had talked about in her keynote earlier this morning. Come by our booth. We'd be happy to talk to you there, and hopefully we'll see you there. Thank you very much.